Okay, now let's talk about one application of simple linear regression. So how do we find the linear model for a given data? For example, here we have a given data from Butler Trucking Company. So it should be under the chapter 7 folder. So we are given this set of data. They have 10 assignments, so that's historical data. So for each assignment, they recorded the miles that the trucks traveled and also the travel time. They want to find the relationship between the miles and the time, and then they created a scatter plot for those data. And this is the scatter plot showing the relationship between the miles and the travel time. So the travel time is the y variable, or the response variable, or the dependent variable, and the x, or the miles traveled, is the independent variable. So there are multiple lines we can consider. For example, I can draw a line like this, or I can draw a line like that, or one more, I can draw a lot of lines. But which line is the best regression model for this set of data? So that's why we have to use some method to find the best regression model. So that method is called the least squares method. So what is the least squares method? That is the method to use sample data to formulate the regression model. So the idea behind this method is to minimize the summation. So the min means minimize. So the objective of this method is to minimize the summation over the difference between the actual y data that we just saw on the previous slides, and the estimated y value. So this value is from the regression model that we formulate and squared. So we want to minimize this value. So the regression model, or the function that gives the smallest number in terms of this formation, will be the best regression model that we need. So the yi is observed value, so that's actual data, and the y hat is a predicted value, and n is the total number of observations. And in our case, if we go back by one more slide, so we got 10 points, so the number of observations is 10. So here I want to introduce one more concept, which is called residual. So residual is denoted as small e. So the definition of residual is the difference between the actual data, or observed value, and the estimated value. Okay? And if we go back to the least squares method, so that's the formulation. So we can write this objective function using the residual, because the residual is just the difference between the observed value and the estimated value. So basically, we are trying to find the regression model that can minimize the sum of squared error, or the residual. So we call it, because we have square, we call it squared errors. So let's see how we can do this in the Excel using the data we have. Okay, so that's Butler's data. Okay. So first of all, let's create a scatter plot. We learned how to create a scatter plot in the previous chapters, so we will go really quick. Insert, and here we have a scatter plot. Okay, so let's get rid of the grids, and here is here's our data, and let me put the axis title. So that's going to be miles, and the vertical axis represents I think it should be the travel time in hours. Okay, so we got the data we have. So in Excel, we have the function to formulate the regression model. So in the scatter plot, if you right-click any of the data point, okay, and then there's something called add trend line. So let's click on that. Okay. Now we have a linear regression model, but here we got quite a few options because we are talking about simple linear, and this data looks like simple linear regression or relationship. Let's just click the linear. Okay. And also let's check this one, display equation on chart, so that we will know the parameters or the B0 and B1. Let's check that, and let's also check display R squared value on chart. Let's check that for now, and we will explain what this means. Okay. So that this is we have. Let me make it larger. Okay. So this line is, let me make it too small. I put it over here. So this is the linear regression model that is formulated using the least squares method. So we have the B1 and B0. So those are the estimates of the population parameters. Okay. So that's how we do this in Excel. Okay. So that's the scatter plot that the same as the one we created, and we have the, let me see if our regression model is correct or not. Okay. So B1 is 0.0678 and B0 we got the same number. Okay, here's our regression model. Okay. So y hat is equal to 1.2739 plus the B1 times x1. x1 is the miles traveled, and y hat is the estimated travel time.